This slide is talking. So there's the 5 reactions we expect you to know out of your head. All right. It's fairly straightforward. You must just remember this. Don't even worry about why. A salt plus a metal makes a salt plus, an acid plus a metal makes a salt plus hydrogen. Just learn it. Okay. Acid plus a metal makes a salt plus hydrogen. Or the next one, an acid plus a metal oxide makes a salt plus water. Question number 3, acid plus a metal hydroxide makes a salt plus water. Those two exactly the same. Acid plus a metal carbonate makes a salt plus carbon dioxide plus water. And an acid plus metal hydrogen carbonate makes a salt also plus carbon dioxide plus water. You can see they're going to remember those easy. All right, no problem. The only issue is you need to know if we give you any acid and any metal, you must be able to work out what's salt. And you must remember, oh, is it water as well, or hydrogen, or is it carbon dioxide? Okay. So here I've got a table, and we're going to have a go at working this out. Now, I'm going to start with the right-hand side of the table, and then we're going to go to the left-hand side of the table. The right-hand side of the table, I'm telling you what the acid and the base is, and I want you to work out what the salt is. Now, remember what I said. Just go down here. I said this, so I'm just jumping ahead to this slide. The salt that is made has got a metal and a non-metal part. You agree? Now, I'm showing it like this. The acid is normally got hydrogen in it, or always got hydrogen, and it's hydrogen with a non-metal. The base is a metal with an OH. Now, how do those things combine? The metal of the salt comes from the base. The non-metal of the salt comes from the acid. Okay, so that's a kind of a general example. And this one here is a specific example. Hydrochloric acid and sodium hydroxide. The salt that's going to be made is sodium chloride. The sodium comes from the base. The chloride comes from the acid. And here I've said it in words. The metal part of the salt comes from the base. The non-metal part of the salt comes from the acid. That's what you need to remember. If you remember that, you'll be fine. Now, I made another slide to show the same thing. There's your acid and there's your base. What happens? They make a salt. So the metal part of the salt of the base comes and makes the metal part of the salt. The non-metal part of the acid comes and makes the non-metal part of the salt. It's the same information, just presented differently.
Back on slide on this slide.
I will just get this one. When you add those two things together, when you add an acid and a base, this is what happens. Oh, there. That plus is, it's usually plus water or something. Usually makes water as well. There's other things. So you got that one and you got this one. You got that all down. Now here I've said H2 in brackets O because sometimes it makes just hydrogen and sometimes it makes water. So nothing, it just makes whatever else it makes. So it's either water or H2O because you're going to learn these 5 reactions. Okay, you're going to learn those 5 reactions and you're going to say, I know this is acid plus a metal, so it's going to make a salt plus hydrogen or whatever. So let's try these. If you have a hydrochloric acid and magnesium hydroxide as your base, what's your salt going to be? Cl2. Did I do that one for you? Okay, it was done for you. Yeah. So what's your salt going to be in the next one? Sulfuric acid with sodium hydroxide. NaSO3. What's the valency of SO3? 2 minus. So how many NAs will you need? Na2SO3. Yep. Yeah, because what happens to the hydrogen? Goes to the water. Now, I need to change the fourth one. I need to change the fourth one because it's a bit of a daft example. The next one. How many CO3s? What's the valency of Ca? 2. What's the valency of CO3? Yeah, CO3. Now, I need to change the next one. I've had it like this for years, and it's not very good. Let's make this. Let's make this. I'm going to change this. Let's make this HNO3. What's the answer to that one? Don't say no clue.
I don't even know if it's an acid or base, so I'm not getting.
You have to just learn them. You got to just learn them. Bases have usually got OH in them, and acids have normally got acids, but you got to just learn them. Calcium nitrate, CaNO3 2. Okay, CaCO3. Now, in the next one, I'm making it a bit harder. That goes to make carbon dioxide. Yeah. So this last one, I'm making it a bit harder. I'm telling you the acid. I'm not telling you the base, but I'm telling you that in the salt, you've got magnesium. So your magnesium's got to be in the base. Now you can use any base with magnesium. So remember, all of these are bases: the metal, metal oxide, metal hydroxide. So you could use the metal. You could just say here, if you wanted to, you could just say magnesium. Or you could say magnesium oxide or magnesium hydroxide. It doesn't matter. But
so that going to change what it forms.
No. No. Because it's not going to change the salt. It might change whether you make carbon dioxide or whether you make water. Thomas? Yeah. But it won't change the salt. Yeah. Yes. All right. Happy so far? Now, Mr. Latham, you're doing an awful lot of chatting there. Now, on this side of the table, we're going to do it a little bit more difficult. Instead of giving you the acid and base, I'm giving you the salt. So, if you want to make the salt MgCl2, what acid do you need? HCl. Because the acid is going to have the chloride anion, and there's only one, HCl. Now, what base? Any base that's got magnesium in it. You can use magnesium, you can use magnesium oxide, magnesium hydroxide, magnesium carbonate. It doesn't matter. What I want you to do when you do these ones, can you always use a different base? Don't just use the metal every time. If you use the metal on the one, then use the metal oxide, then use the hydroxide, then use the carbonate or the hydrogen carbonate. Don't use the same base every time. And finish those quickly. Let's have a look. You can't just use an iron. So the reason you can't just use an iron is this. Remember, if you're going to go and buy this reagent in the shop, or whatever, you're going to get a bottle of it. How many molecules are in there? Within it. Okay, remember, if you get about 2 grams or whatever, there's going to be at least a mole of substrate, and a mole is like if any single particle is charged, it takes 2. That whole thing is going to be maximum charge. What's that for? Plus, it be a minus. It's going to be the engine for me. Yes.
The second one, the second one, I've like the H, and the speed.
And still work. But you can use any iron base. Any base that's got iron in it. So you could use FeO. For the base. So the bases are either got to be the metal oxide, or the metal hydroxide, or the metal carbonate. Now carbonate is CO3. So if you want to use FeCO3, you can, but which Fe is this? What's the charge on this iron? 2+. So you must use the 2+ ion in the salt. So it must be FeCO3, because that's 2- and that's 2+. Are you done? Because here there's 2 nitrates, and each nitrate is -1. Well, we said it's going to be the acid's going to be nitric acid, HNO3, and here you can use any iron base, FeO2. Sorry, FeOH2 or Fe2O3.
Is it Fe bracket OH bracket 2?
Yes. If you use the hydroxide. Third one, acid. Carbonic acid. Can you just use? Well, the acid's got to have hydrogen in it. Remember, all the acids have got hydrogen in them. Yeah? What's your acid going to be? HPO. When you look at the first slide, I've got all the acids on the first slide. If you're not sure which acids they are, they're all on the first slide. You happy with those? You don't have to use the same base as me. As long as you got that metal in the base, it's fine. If you used MgOH2, that's fine. If you used Fe2O3, that's fine. Aluminium one. And now the last one. Well, have a look at it and then tell me what the problem is. So guys, if I meet you in the middle of the night, wake you up in the middle of the night and say to you, acid plus a metal hydroxide, you must just say salt plus water. If you can't, you're not serious about chemistry. Okay, you've got to learn that. Right? Now, acids and ionization. Let's just talk about this a little bit. You need to understand the difference between a strong acid and a dilute acid and a concentrated acid. And the same thing applies to basic. What does dilute and what does concentrated mean? Dilute means lots of water, little bit of acid. Basically, that's it. Lots of water, little bit of acid. That's what dilute means. Okay. Concentrated means lots of acid, a little bit of water. All right. And that applies to acids and to bases. We'll leave it there today.